So we went over these in class of how to do this on your calculator. So this answer, if you had to make sure your calculator is in radian mode, the answer is 2.278862. And this one here, I kind of gave you the hint of like what to make the function equal to. And this is 1.379729. Okay, so those would just be the answers, and that's all you would need to write. But you just need to know how to do that on your graphing calculator. All right, so r sub 3. So this means n is equal to 3. You need to figure out your delta x. So that's 8 minus 2 divided by 3. 6 divided by 3, that's 2. So that means underneath my graph of y equal root x, I'm starting at 2 and I'm going to 8, and each subinterval is of width 2. So I have 3 rectangles, right? You can see them, 1, 2, 3. This says use the right-hand endpoint. So between here, I use this endpoint. There it is. Here, I use this endpoint. Here, I use this endpoint. So my r sub 3 would be the width of 2 times f of 4 plus the width of 2 times f of 6 plus the width of 2 times f of 8. And so just plugging that into the function is all I would need. So 2 times root 4, which is 2, plus 2 times root 6 plus 2 times root 8. Root 8. And that's a fine answer, just like that. Okay, so this one's a little bit different. So this has cube root, and it's using midpoints. Same interval, so same delta x, right? Delta x will equal 2. So it's a cube root, so it's not much different, right? Kind of looking like that. So if I start at 2, I can go to 4, and then 6, and then 8. Okay, so I'm using middle points. So that's these points, right? So my m sub 3, make some room here. M sub 3 would equal the width of 2 and then f of 3, because that's my middle point, plus the width of 2 times f of 5 plus the width of 2 times f of 7. And then your last step would just be to plug those numbers in. So 3 to the 1/3 plus 2 times 5 to the 1/3 plus 2 times 7 to the 1/3. And do not use a calculator or anything like that. That's a fine answer. Here we have a rectangle that I want the largest area. So you're thinking derivative equal to 0, right? So underneath this parabola is a rectangle, and the rectangle is inscribed like that, right? So that's the area equation. So I'm going to call this the length, and I'll call this the height. And I know the area of a rectangle is length times height. Okay, so let's talk about the length. I know that this distance and this distance, they both will be some x value, right? That would be an x, and that would be the opposite of that same number. So the length is going to be 2x. So I'm going to put that in. Then the height, this height here is going to be the y value. So I'll say times y. How do I know how to put y in? Oh yeah, it's the function. So that means it's 2x times 16 minus x squared. So I can take and multiply that out. Actually, do some little bit of simplification before you do the derivative. Whoops, I lost my x. Before you do the derivative, it'll make your life so much easier. So then I'm going to take the derivative. I'm just going to put it right here, save room. 32 minus 6x squared. I'm going to set that equal to 0. So I get x squared is equal to 16 divided by 3. X is equal to plus or minus 4 over root 3. And I don't care about rationalizing denominators. That's just fine. So the width, or the length here would be 2x's, right? Let me just say length would be 2 times 4 over root 3. And then the height would be putting this x value into the function, right? 16 minus, and then that would be 16 over 3. So that's fine to leave your answers like that.